The biggest star in the universe. Hello everyone! Welcome to our channel. In today's video, Smart is the New Sexy is going to tell you about the biggest stars in the whole universe. No, it's not about the sun. We will tell you everything we know about UY Scuti and R136A1. With the development of technology, astronomers discover planets, asteroids, and stars almost every day. New ones make others look like dwarfs. Although the list of the most massive stars is pretty solid, there might still be some changes. Even our sun looks tiny when compared to the biggest stars we know of. However, there are two main parameters that we'll use to characterize stars: their mass and their size. Enter UY Scuti, a bright red supergiant variable star that resides within the Scutum constellation and is currently believed to be the largest star in the Milky Way galaxy. The huge star could fit more than 1,700 of our suns. Let's imagine for a moment that the Earth was an 8-inch diameter ball. At that scale, the Sun would be about 73 feet in diameter, which is a few feet more than the height of the White House. Our enormous distant friend, UY Scuti, would be 125,000 feet in diameter, which is just a smidge under 24 miles. UY Scuti was officially named the largest known star in the galaxy, surpassing previous record holders such as Betelgeuse, VY Canis Majoris, and NML Cygni. If UY Scuti were to swap positions with our Sun, it would engulf the entirety of Jupiter's orbit, swallowing the Sun, the first 5 planets of our solar system, and the asteroid belt. So, with all confidence, we can say that UY Scuti is the largest star in the universe. But what about the rest of the universe? We bet there are a lot of things that are more massive than UY Scuti. There are black holes, of course. Our Milky Way hosts one that is about 4 million times the mass of the Sun. One of the biggest supermassive black holes ever found is located in NGC 4889. That black hole is roughly 21 billion times the mass of the Sun. As for the size, there are several candidates that are just as huge as UY Scuti. They would include NML Cygni, whose estimated distance is about 5,300 light-years away, and whose radius is thought to be 1,650 times greater than that of our Sun. A recent study of this star suggested that it's an unusual hypergiant star, cocooned within a nebula and severely obscured by dust. Thus, we don't know its size exactly, and the true range might be between 1,642 to 2,775 solar radii. The upper part of the range would make it larger than UY Scuti. Another hypergiant star is WOH G64, also in the Large Magellanic Cloud, and thus located at a distance of some 168,000 light-years from Earth. At an estimated 1,540 times the Sun's radius, this star is thought to be the largest star in the Large Magellanic Cloud, in terms of sheer physical size. And again, we're talking size here, not mass. This star is thought to have only 25 times the Sun's mass. Astronomers using the unique ultraviolet capabilities of the Hubble Space Telescope have identified 9 monster stars with masses over 100 times the mass of the Sun in the star cluster R136. This makes it the largest sample of very massive stars identified to date. R136 is only a few light-years across and is located in the Tarantula Nebula within the Large Magellanic Cloud, about 170,000 light-years away. The young cluster hosts many extremely massive, hot, and luminous stars. The current record holder of the cluster is enormous R136A1, with more than 250 solar masses. It can only be seen with the use of powerful telescopes in the southern hemisphere. If the star took the place of the Sun in our solar system, its gravitational attraction would pull our planet in so close that the length of a year would shrink to 3 weeks. At that time, the extreme properties of these stars came as a surprise, as they exceeded the upper mass limit for stars that was generally accepted. It's still unclear how such behemoths could be born, and astronomers raise many new questions about stars' formation. One idea is that supermassive stars like R136A1 form through mergers of multiple stars. In a closely packed star cluster, double stars are more likely to encounter each other and merge. Unlike humans, these stars are born heavy and lose weight as they age. It's possible that R136A1 was even more massive than it is now. Such heavyweight stars are extremely rare, forming only within the densest star clusters. So, R136A1 is the heaviest star known to exist in the observable universe. Lightweight stars, such as our Sun, live a long and quiet life. Massive stars, on the other hand, are very rare and have a short but intense existence before exploding as supernovas. Star R136A1, discovered thousands of light years away from the solar system, the most massive star found to date. Like other giants, it has a large radius for its mass and surface temperature, over 40,000 Celsius. Its brightness is hundreds of thousands of times greater than that of the Sun. So, UY Scuti versus R136A1. Let's compare. UY Scuti, 7 to 10 solar masses, 1,700 solar radii. R136A1, 265 solar masses, 28 to 35 solar radii. Since we're still on the topic of record breakers, why don't we talk about the oldest star in the universe? In new observations of a distant region of primitive stars, astronomers have found the oldest known planet, a huge gaseous object almost 3 times as old as Earth and nearly as old as the universe itself. It's called Methuselah. According to the Big Bang Theory, the universe was born around 13.7 billion years ago. Methuselah is about 12.7 billion years old. To put things into perspective, the universe itself is just 1 billion years older than this planet, and our Sun is just about 4.3 billion years old. Methuselah is 2.5 times bigger than Jupiter and 800 times the size of Earth. Methuselah has no life, nor does it have any moons. Do you want to know more about other record breakers of the universe? Share your ideas in the comments. If you're curious, subscribe to our channel to keep up with what's going on in the world and beyond.